section 4.2. So that's what I had for you guys to print out was 4.2. Okay. Can you see the slideshow, Matt?
Yeah.
Okay. That was yes, right?
Yep.
Okay, cool. Okay. So chapter 4 review. We're going to just look at 4.2 because that's mostly what is on the final exam, okay? So we're going to take what we did before in section 3 with the polynomials and take it like the next step further. So most of the stuff that we're going to be talking about today are how do we find an asymptote? What does it mean? What does it look like? Things like that, okay? But let's first start off and do the function, which is the first box. I mean, the definition, which is the first box. A rational function is a function in the form of Rx equals Px over Qx. Okay. So I'm not going to write on boards today. I have them in my PowerPoint slides. Okay. Where P and Q are polynomial functions. Okay. So they're both polynomial functions. X plus 3. X squared minus 4, something to that effect. Sorry. Okay. Q cannot be the zero polynomial. Why can't Q be 0? Where is it at in my little fraction up here? It's on the bottom, right? So it can't be on the bottom. So Q cannot be anything that's a zero polynomial, okay? The domain of a rational function is the set of all real numbers, except where Q is what? This is what we've done before. 0, right? When we talked about the domain of function, we started out with a set of all real numbers. We get rid of anything that's on the bottom of a fraction, right? Equaling 0, because it can't equal 0. And then we look for any kind of square roots and see if there's negatives, right? Those are our 3 steps. So the domain is going to be a set of all real numbers as long as Q is not equal to 0. Okay? Let's do an example. I just pulled out 2 off of the sheet. I think it was the top 2, A and B. So if I'm going to look at A over here, x squared minus 4 divided by x plus 4. What's that domain going to be? Start out with all real numbers, right? What do I subtract? X plus 4 can't equal 0, right? So my domain of this is all real numbers except when x is -4, okay? If I come over here, I'm going to do the exact same thing. I'm going to take that denominator, set it equal to 0, and that's where I cannot be, okay? Same reason that we just did, okay? X plus 4 equals 0, or cannot equal 0, I guess I should say. X cannot equal -4. Over here, I take my x squared plus 8x plus 12. It cannot equal 0. Again, you can't have a 0 in the denominator, right? I factor that out. My factors of 12. I have 1 and 12, right? 2 and 6. 6 plus 2 is 8, so I use my 2 and my 6. X plus 6, x plus 2 cannot equal 0. So now I've got 2 different choices, which makes sense, because what is my exponent on the bottom there? 2, right? That means I'm going to have 2 answers. So for this, I just set one of these, well, set them both equal to 0. X cannot be what? -6 from the left. X cannot be -2 from that part on the right. Do those make sense? We haven't done anything like crazy or even new yet, right? This is kind of just extending on what we did last week.
We just struggle with factoring so much.
Do what?
We just struggle like finding something that you can add and multiply. I just struggle with that so much.
These? Yeah.
Like in high school, I used to struggle with.
Yeah. I had a teacher tell me that trick about what are all the factors of 12, and he used to write them out like 1 and 12, 2 and 6, 4 and 3. And then he'd be like, okay, can I take any of these pairs and make an 8? by either adding or subtracting. I think that for me was like my light bulb moment with factoring. So I was like, oh, because like at first it just seems like random numbers, right? Okay, but six times two, so I mean it makes sense in the end. But yeah, I struggled with that for quite some time too. Okay, we're gonna graph the following functions. Bottom of page 1 here. The graph of 1 over x is gonna look something like this, where you've got two different swooshes, right? You're staying completely in the positive, oops, or the negative, negative. Okay? You look at this, if your x is positive, your y is going to be positive. If your x is negative, your y is going to be negative. So you end up with your swooshes. Okay? The one next to it, if I square that bottom, I look very similar in that positive section, right? A little bit further up. But this negative one flips up and goes positive. Right? My x is negative here. Negative times a negative is always going to give me what? Positive. So this graph can never be below 0. Okay? There's nothing I can put in for x to give me a negative y. Okay? Now, if we take this and combine it with what we did last week about that transformations, x minus 3 squared plus 2. Remember, we did those transformations last Thursday, right? Let's start with 1 over x squared. Okay? Don't draw on your paper yet unless you want to draw all of them. Okay? Let's look at that 3. What is it associated with? What's it next to? X. So where is it going to move? On the x. Okay? Minus 3. Okay? So which way is it going to go? It's actually going to go this way. It goes the opposite side on x. Okay? So see here, my center was at 0, 0. My center has now moved to 3. Okay? This would be the graph of 1 divided by x minus 3 quantity squared. Okay? I want to add a 2 onto the end. Where am I adding that 2? Is it associated with the x or the y? It's the y, but it's not sitting right next to the x, right? So it's the y. Which way does y go? Up and down. So where do we think this is going to move now? Up 2. Up 2. Okay? You can use the same rules with these rational functions that we did with those polynomials before. Okay? So you're going to have a swoosh. It's never going to touch 3, and it's never going to touch x equals 3, excuse me, or y equals 2. Okay? So it kind of took your origin and put it at 3, 2. Okay? Questions? The same thing we did before, right? Same rules apply. Okay? Now we got lots of words. We got lots of definitions. I actually skipped the bottom part. We don't really need that. We're going to go to the next page, top of the next page.
We don't have the x-ray.
Because that was mostly like plug things in your calculator and graph and stuff. And we're not going to do that. Okay? But let's look at these horizontal and vertical asymptotes. So what's an asymptote? Do you guys remember? Not really. It's something you are going to get super duper mega close to, but you're never going to be equal to, and you're never going to cross it. Okay? This first picture, for example, is getting super duper close to that dotted line. It's never going to be equal to that dotted line. It's never going to cross that dotted line. Okay? If I go back, we have one of those dotted lines here at x equals 3, going up and down. It's never going to be equal to 3. Because what happens at 3? My bottom is 0, which is illegal. We can't do that, right? So it's never going to be 3. And we've got our other asymptote at 2. Okay, so let R denote a function. Okay? If, as x approaches negative infinity, or as x approaches positive infinity, okay? So as we are going out, okay? I think they may have had a study hall in here. Okay, so as x is approaching negative infinity, or as x is approaching infinity, the values of y are approaching some fixed number, L. Okay? Could be any number, doesn't matter right now. Okay? Then the line y equals L is an asymptote. It's never going to get there. It's approaching that number, never going to be equal, it's never going to cross. Okay? Then L is a horizontal, because L equals something is a horizontal line, right? So it's a horizontal asymptote of the graph. Okay? Here, look at your pictures A and B, the first two. Those dotted lines are horizontal, right? Here's your y equals L for A, and y equals L for B. Okay? You see you've got arrows that are approaching it. You never go across it, never going to be equal. Okay? Now, as x approaches some number c, the values of y going toward the absolute value of y going to infinity. So, for example, y goes to negative infinity or positive infinity, right? That's all I did with the absolute value. Okay? So the absolute value of r of x, or y, the function, is going to infinity. What do you think the vertical asymptote is going to be? We're getting close to number c. The number c? Sure. The value of c. So your x equals c, does that make sense? Is your vertical. X equals a number is going to give you a vertical line, right? X equals 2. Going to line at 2. Okay? So, as x is approaching some value, we can say that that asymptote is going to be at that value. Look here at C and D, the second two. We've got a vertical dotted line on both. For C, we've got it going from some value to positive infinity as far as y is concerned, right? But again, it's never crossing that x. And for D, we've got one going positive infinity, one going to negative infinity, but it's never going to cross that x. And it's still okay, correct? Yeah? Can the graph of a function intersect a horizontal asymptote? No. Okay? You cannot intersect, you can't cross over, you can't ever be equal to. Okay? It means we are getting super duper close and we're never going to be equal to it. Okay? You guys good with this box? Yeah? Okay. The next couple problems on that sheet go through graphing calculators, so I'm going to go to the table on the next sheet, actually. I'm going to look at the first two. We're going to pull them apart a little bit. We're going to examine them, and then we're going to come up with some rules about them, okay? So let's look at the first one, okay? F of x equals 3x plus 1 over x plus 1, okay? You can hardly see my graph on the screen. You can see a little bit better online, okay? It's a graph that goes here and one that goes that way, okay? Apologize, you can't see it right now. What is the leading term in the numerator? 3x, right? Look at you go. You're kicking butt. What is the leading term of the denominator? Huh? You don't know? What's the denominator?
What do you mean? It's the x.
X, right? The 1. Okay. Remember, if there's no number in front of a letter, it's an implied 1. Okay? So, my equation of the horizontal asymptote, remember, horizontal, y equals something, is y equals 3 over 1. 3 over 1. You see that? That's interesting, right? The equation of the vertical asymptote, on the other hand, is going to be -1. So you've got a horizontal asymptote here at 3, and you've got a vertical one here at -1, which is really hard to see on the screen, and I apologize.
Why is it -1? Is it just because turn goes into it?
What happens if my bottom is a -1? I end up with -1 plus 1. What does that give me? And what can I not have on the bottom? 0. Exactly. That make sense? Okay, so that's going to be where that bottom denominator cannot be equal to 0. Okay, let's look at the second one. Ooh, my graph came out a little bit better on this one. Okay, x plus 2 divided by 2x squared minus 2. What's my leading term for the numerator? X, right? 1x. What is my leading term for the denominator? Well, I got 2x squared. They're different this time. Right? What were they before? Let's go back a little bit. 3x and a 1x. They had the same exponent, right? Well, now we're a little different. So we got a little bit different things going on. Okay? Horizontal asymptote is going to still be at 1/2. What's the vertical going to be? Because of my bottom? 2x squared minus 2 cannot equal 0. Okay? -1 and +1. Right? I've got a vertical at -1. I've got a vertical at +1. You could see that in the graph, right? You got something happening over here. You got something happening over here. We got something happening between -1 and 1. Okay? Because if I'm either going to be at -1 or 1, it's going to be a 0 in the denominator. Illegal, bad choices made in life, right? Okay. Let's look at the vertical asymptote and how we figure that out, okay? A rational function of r with p over q, okay? We'll have a vertical asymptote at what? X equals r, okay? If r is a real 0 of the denominator, right? What does that mean? What it means is set q of x equal to 0, find out what it can't be, what's illegal. That's what it can't be, okay? That's the vertical, okay? Let's do, there we go, let's do 2 examples on the next page, the first 2 problems, okay? Find the vertical asymptote, okay? Remember, what can't be 0 for vertical? The denominator. What would it be for r of x for the first one? X cannot be what? What would the asymptote be? You have 3 plus x equals 0. What would x equals what?
-3.
What kind of 3?
Negative.
-3.
But I thought you said it's 3 and 3 on the that's +3, that's -3.
3 plus a -3 would give me 0 down here.
They say clean it.
Right. So my asymptote is at x equals -3. For the first one. You see what I'm saying?
Oh, okay.
It's gonna get super duper mega close to -3, but you can never be equal to -3. Okay? Does that make sense?
Yeah.
Okay. I think we were saying the same thing, but not really. Okay. What about the one over here on the right, the h of x? What numbers can I have?
2.
+2, -2, right? They were nice, they gave it to me factored. I didn't even have to factor it, right? X plus 2 equals 0, -2. X minus 2 equals 0, +2. So my 2 asymptotes are at x equals 2 and x equals -2. Does that make sense? That's the easier one out of the 2 asymptotes to find, is the vertical. Right? Just where you're illegal. Make sense? Yeah? Okay. Now, let's get into the harder ones. The horizontal or oblique, okay? We'll talk about oblique in a second. An oblique would be an asymptote of a line, something that's not necessarily horizontal or vertical, okay? So, let's take it step by step. I've got P over Q equals X to the N over X to the M, okay? What we are really looking at are what those exponents are, M and N, okay? If N is less than M, your denominator is bigger than your numerator, okay? Your asymptote line is going to be y equals 0 for horizontal, okay? So if you have a larger exponent on the bottom than on the top, y equals 0, okay? If they are equal, this is the very first one that we did a couple of slides ago, right? What did we do if they were equal? We took the coefficients in front and divided them, right? So it's the coefficient in front of the numerator divided by the coefficient in front of the denominator, okay? So your horizontal asymptote, if your powers are equal, is going to be A divided by B, okay? That's your value. Does that make sense? Okay? If N, the top, equals M plus 1, okay? So if your top is 2 and your bottom is 1, okay? If your top is 3 and your bottom is 2, if they're one off with the top being higher, you're going to have what's called an oblique asymptote, which is going to be some kind of line. So you're going to have it in some form of y equals ax plus b. Okay? How you find that line is you divide the two equations. Remember we did division like chapter 1, 2, maybe appendix A? Okay? You divide, and it's what you get rid of, just ignore the remainder. Okay? If your N, the top, is greater than or equal to twice the bottom, there are none. There are no horizontal or oblique asymptotes. Okay? You can never have a horizontal and an oblique. That's what that note says. But you can have a situation where you have neither. Okay? So it's none, one, or the other. It's never both. Does that make sense? Because you can't have an asymptote like this if you have one like this, right? It's not going to happen. Okay? Does that kind of make sense? So those are going to be our rules that we want to follow when we look at the horizontal asymptotes, okay, or obliques. Let's do one last example. Find the horizontal or oblique asymptote if, okay? It's the very, very last one on the page, the one on the very bottom. Sorry about that. 2x squared minus 3x plus 2 divided by x minus 1, okay? What is my M and my N? Okay, so from that table that we just, or the box that we just filled out, my N is the power of the top, which is 2, right? My N is 1. Remember, letter by itself, no exponent, it's an exponent of 1. Okay? If I look at that table that we just, or that box we just filled out, my N equals M plus 1, right? 2 equals 1 plus 1. So I'm going to look at that number 3 off of the box on the page before. Okay. The box before, the one we just filled out.
No, it's not.
Oh, I'm sorry. The
Okay.
box we just filled out.
I thought we were on the same page.
No, I know. Okay, right? Because the first one is n less than m? No, so it's not number one in that box. Are they equal? No. Is n equal to m plus 1? Yes. So I rewrote 3 down here just for us to do it for example, okay? So that is the rule that we're going to follow when we look for this horizontal or oblique. Okay? Because we are at number 3, it's going to give us a line, and it is in fact an oblique. Okay? I know that much just by looking at it. Okay? Now remember, it's found using your long division. So, I tried to make this look as good as I could on a slide. You kind of get the idea, right? Kind of, okay?
That's just good.
No, it's divided by.
Oh.
Difference.
Okay.
Big difference, right? 2x squared minus 3x plus 2 under a divided by sign, the radical for divide by, with an x minus 1 on the outside. Okay?
Wait. So it's,
We're doing this
yeah, but flipping.
in the long division. Okay? What can I multiply x by to get 2x squared?
2x.
X, and what about the 2? Okay? So I get 2x squared minus 2x, but then you subtract everything, so it's plus 2x. And I get x plus 2 left over. Does that make sense? You guys kind of remember what that looks like a little bit? Okay? X can go into x 1 time minus 1. So my equation is 2x minus 1. I can stop there. I don't really care what my remainder is for this. Okay? I do have a remainder of 1. I don't care. I don't care what the remainder is. Okay? I know when you guys were doing the actual long division, you would say the remainder is 1 divided by, x minus 1. We don't need that. So we have an oblique asymptote at y equals 2x minus 1. Okay? It's as simple as that. Look in that table. Look at your n and your m. You'll find out what you need. Does that make sense? Kind of ish, maybe sort of. Maybe sort of, kind of, maybe. Okay. The last slide I have here is I actually took this and I graphed it so you can see what it looks like. Okay. So here is my 2x in red minus 2x squared minus 3x plus 2 all divided by x minus 1. Okay. My oblique asymptote is at 2x minus 1. That's that blue line. Do you see how they're kind of getting close to it, but they're never going to cross it? Okay. You can also see here what oblique means. Okay, it's a slanted line. Can be negative, can be positive, doesn't matter. It just means it's not completely horizontal, it's not completely vertical. Okay. We go back to, real quick, because that's all I have on these slides. If I go back to this box, okay, for 1 and 2, I'm going to get a number. Okay. For number 1, y equals 0. That's my asymptote. Okay. For number 2, I'm going to take those coefficients and I'm going to get the number. Now, if I take that, if I say these are equal and I have a 2 over 1, what's my asymptote? Y equals 2. Right? If I said these were equal, if I said my exponents were equal.
Okay.
Okay? So really, those are the 3 parts of it that you need to remember for horizontal. What was vertical again? Vertical was taking that denominator and finding out where that denominator is 0. A little bit easy to remember, right? Horizontal and oblique has a little bit more, few more rules. Okay? So for the final, I suggest you kind of remember those 3 if you can. Yeah? Questions? Comments? Concerns? That's really all I have. Oops, that worked out well. That's all I have for this review. I'm gonna go ahead and stop recording, maybe. Stop recording. Okay.